Picture a 20-ton block of dark basalt, carved into a human face taller than a person, sliding slowly through tropical lowlands without a single wheel or draft animal in sight. That is the logistical problem at the heart of the Olmec stone heads, and it is one of the most striking ancient engineering feats in Mesoamerican archaeology. The Olmec civilization flourished along the Gulf Coast of what is now southern Mexico between roughly 1500 and 400 BCE, with major centers like San Lorenzo and Venta sitting on low plateaus above swampy plains. These were not desert or highland cities with easy stone access. They were nodes in a humid, river-laced landscape. The colossal heads we associate with them were not carved from local rock. Geologists have traced most of the basalt back to the Tuxtla Mountains, particularly the Cerro Centpec volcanic region, roughly 60 miles or about 80 to 100 kilometers from those sites, as the crow flies, and likely longer along workable routes. That baseline fact already tells us something. Olmec elites were willing to mobilize huge labor forces to move stone across serious distances simply to install portraits in their ceremonial centers at a time when there were no carts, no pack animals, and no metal tools. The first step in moving these Olmec colossal heads was not movement at all, but quarrying. Basalt in the Tuxtla Range occurs as massive flows and boulders. Workers using stone hammers and perhaps harder cobbles would identify suitably large blocks, exploiting natural fractures and joint lines. Experimental archaeology and toolmark studies suggest a slow, repetitive cycle of pounding, chipping, and wedging to detach a core, with fires and water quenching possibly used to weaken surfaces. In some cases, the archaeological and sculptural evidence suggests that blocks were roughed into throne-like shapes first, and only later recarved into heads, so part of the shaping may have been done near the quarries, where waste chips could be discarded on the spot. That makes engineering sense. Every kilogram of rock left in the mountains is a kilogram that does not have to be dragged across mud and riverbanks. Even before the stone traveled those 60 miles, teams had to detach it, reduce excess mass, and produce a stable shape that would not crack under its own weight when dragged or lifted. The heads we see today range from around 6 tons up to 40 or even 50 tons. So it is likely that the original blocks were heavier and trimmed down as the project advanced. The next challenge was getting these proto-Olmec stone heads out of the mountains. The Tuxtlas are not gentle hills. The terrain is steep, forested, and cut by streams and ravines. Archaeologists do not have preserved Olmec instruction manuals, but physics and ethnographic analogy point toward a combination of wooden sledges, rollers, and prepared paths. A massive block could be laid on a thick wooden sled or cradle, then hauled downslope by teams pulling on ropes made from agave or other plant fibers. Tree trunks or rollers laid ahead of the sled would reduce friction. People at the back and sides would control speed with levers and chocks to avoid lethal runaways. Crews would have to cut vegetation, build temporary ramps, and maybe even backfill small gullies so the sled would not snag. Even today, experiments with teams pulling multi-ton stones show that with enough people, rhythm, and good coordination, you can move impressive weights with very simple technology. The Olmec were no exception. What they lacked in hardware, they compensated for in organized human effort and detailed local knowledge. Once the stone reached lower ground, the environment began to work in their favor. The San Lorenzo region sits near the Coatzacoalcos river system, and La Venta is on an island in a swampy plain connected to a network of waterways. When geologists and historians try to reconstruct the route, they typically imagine a mixed overland and riverine journey. Drag from basalt outcrops to a navigable stream, then float as far as possible on rafts or large canoes before another overland leg to the final plateau. A 20-ton block on a wooden raft sounds extreme, but the physics is simple. If the raft is broad and well braced, it will displace enough water to float as long as the draft stays within the channel depth. That would have forced planners to time movements with high water seasons and to choose river branches and backwaters where sandbars and rapids were manageable. A plausible scenario is that workers drag the basalt from Cerro Centpec to a stream, lash it onto a timber raft. Reinforced with crossbeams pole or tow the raft downstream and along the Coatzacoalcos system using smaller boats and ropes, then unload near the base of the plateau below San Lorenzo for the final uphill pull. None of this required formal mathematics on paper, but it did demand intimate knowledge of local hydrology, flood pulses, and channel behavior tested over generations of river travel. The finishing leg to the site is where social organization becomes as important as engineering. To take a 20-ton block up even a modest slope, you need hundreds of people pulling in coordinated bursts, with foremen setting rhythm and others lubricating the path with wet clay, sand, or plant oils to adjust friction. Logs driven into the ground could serve as anchor points for pulleys or simple compound rope systems, multiplying the force a pulling team could exert. Archaeologists sometimes estimate that moving a single colossal head from quarry to plaza could involve tens of thousands of person-days of labor when you factor in cutting timber, building sledges and rafts, clearing paths, maintaining camps, and feeding everyone along the route. That scale of effort implies centralized leadership, the ability to command or persuade communities to contribute, and systems of provisioning that turn maize fields and fishing grounds into energy for a monument transport machine. The heads at San Lorenzo appear to have been arranged along processional routes and plazas paired with massive stone thrones and other sculptures, suggesting that this investment was about more than moving rock. It was about making power visible in stone. If, as many scholars argue, the individualized facial features and distinct headdresses on different heads represent specific rulers or important figures, then every phase of moving an Olmec colossal head was also a political performance. People in villages along the route would have seen the great stone masses pass by, inching toward the sacred center, their arrival signaling that a ruler had risen, died, or been transformed into an ancestor. That might help explain why some thrones seem to have been recarved into heads. Reshaping a seat of power into a portrait is both recycling stone and sending a strong message about succession and continuity. From a technical perspective, carving and finishing might be distributed along the route and concentrated at the destination. After the basalt arrived at San Lorenzo or Venta, sculptors with specialized skill could refine the features, headdresses, and ear ornaments in situ. This makes sense because final detailing is easiest to control when the stone is stable in its final position. It also limits the risk that a finished face would be damaged by a slip during transport. Toolmarks on the heads were studied are consistent with hammerstones and abrasives, rather than metal chisels, which means shaping those distinctive lips, cheeks, and helmet-like headgear was a slow, controlled process that layered thousands of individual blows and rubs into a polished final surface. The fact that heads could be reworked features sharpened. Headdresses modified also tells us that these monuments stayed politically active over time, not frozen the day they arrived. Archaeologists can also see that their story did not end when they were first set up. At several sites, colossal heads were later buried, moved, or deliberately defaced, noses flattened, eyes damaged, surfaces reoriented or half-sunk into new platforms. That kind of treatment is rarely accidental for objects this large. It suggests that later generations renegotiated what the monuments meant, sometimes honoring them by reburying them in new ritual contexts, sometimes perhaps overthrowing the memory of earlier rulers in very literal, physical ways. Moving ahead a second time, even over a short distance within a site, meant returning to the same basic toolkit of ramps, ropes, and sledges, but now deployed inside an already built ceremonial landscape. The colossal heads were not just hauled into place once and ignored. In some cases, they were folded repeatedly into new building programs and new lines of movement through the site. That links the engineering story directly to long-term political change. When people ask how did the Olmecs move giant heads 60 miles, it is also worth being clear about what we do not know. No Olmec texts survive to describe logistics. Organic materials such as ropes, bindings, and wooden sledges have rotted away, and the humid tropics are hard on traces like wheel ruts or prepared causeways. Some modern summaries even say bluntly that nothing certain is known about transport beyond the geological sourcing. That caution matters. Reconstructions that involve log rollers, rafts, drag paths, and large pulling teams are well grounded in what is physically possible and in parallels from other pre-Columbian engineering projects. But they remain models, not eyewitness accounts. Archaeology can map basalt sources, weigh heads, and date their contexts with radiocarbon and but it only glimpses the day-to-day organization through indirect clues like quarry debris, possible staging areas, and wear patterns at landing spots and ramps. Still, if you step back and look at the whole system, the picture is surprisingly coherent. Basalt from a specific volcanic zone moved roughly 60 miles through a mixed river and overland. Network carved into portrait heads that stand in plazas at the political heart of Olmec, culture aligned, with other monuments in ways that guide movement and sightlines through the site. The heads face particular directions, cluster in groups, and sometimes mark boundaries between public and more restricted spaces, turning the result of pre-Columbian engineering into a permanent architecture of authority. Even without written explanations, the combination of geological sourcing, site planning, and sculptural detail tells us that ancient transportation methods in the Gulf lowlands were integrated into how the Olmec imagined authority, ancestry, and landscape. In that sense, the colossal heads are not just Mesoamerican art, they are frozen snapshots of pre-Columbian engineering in action, showing how a society without wheels or beasts of burden could still move mountains, one carefully managed haul at a time. If you follow that chain of evidence through the rest of the video, you start to see the Olmec stone heads not as mysterious anomalies dropped into the jungle, but as the logical outcome of a civilization that learned how to turn rivers, forests, human labor, and political theater into a long-distance transport system built to move stone stories and power across the lowlands.